Hello and welcome back. In this video we're going to continue looking at processing data stored in files. And we're going to do so using a worked example that's ultimately going to lead to us drawing graphical plots of data read from files. But we'll get there bit by bit. So to begin with, imagine we've got a file called meantemperature.txt that contains across 4 columns the month, day, hour, and mean temperature for each reading, and a separate reading on each line. Each of the items is separated by white space, so there's a space between the month and day and so on. Our job in this first example is going to be to find out what's the maximum temperature contained in our file. And in this case the file's tiny, but you could imagine the process would be exactly the same regardless of the size of the file. So our code to do this is going to use an accumulator pattern. Remember, accumulator pattern begins with no data in a list and gradually accumulates only the data we're interested in. We'll do so by opening the file meantemperature.txt, and infile refers to that file object. We then create our initial empty accumulated set of data, so meantemps is an empty list, and for each line in our file object we'll make data refer to the split of that line. So this will create a list where each list contains the 4 objects on each line: the month, the day, the hour, and the temperature value. The only bit that we care about from this data is the 4th bit, so index number 3, 0, 1, 2, 3. So we're going to take out the temperature component, which refers to the float value from the index number 3 in that list of objects on that line. Okay, we then append to our accumulated list that mean temperature. So this just builds up our list, running the accumulator pattern bit by bit, gathering up more and more data. The final thing we need to do is to use the max function to find out what's the max of just those temperature values and print it out. And finally, close the file so that we release the resources associated with holding that file open. So we can run that, and unsurprisingly from our mean temperature example, the highest temperature that we've seen there is 11.7. So that's a simple example of taking each of the lines, splitting them up into their separate components, extracting the data we care about, and gathering it, accumulating only that data. Okay, so this is fairly typical because the data files that we need to deal with usually have a whole bunch of information that we don't care about, much more than we've shown in that previous example. So not only are we discarding the month, day, and hour data, we might also be discarding headers and footers that we don't care about. And we'll see examples of that on the next slide. So we need to think of an algorithm, a process, if you like, that's going to allow us to extract only the data we require. And that's what we're going to do across the next series of slides. So here's the data from NIWA that we're wanting to process. It contains a lot of information beyond the stuff that we want. What we want is the month and the day and the total amount of sunshine for each of those days. But we've got to find a way to extract just the stuff we want and ignore the stuff we don't want. So to help us think about our algorithm, here's just in that same example data so we can see it while we're thinking about how to process this file. So one algorithm would be, and there are many, you can think of your own, is to skip the lines until we get an empty line. So none of this stuff on lines 1 to 7 is relevant to us. It's not the data we're wanting. Remember, we just want the day, the month, the day, and the sunshine hours. So we want none of that stuff, so we can skip lines until we get to an empty line. There's our empty line. Then skip 2 more lines. That's the next part of the algorithm. And why? Because we don't want that one. So there's our empty line. We then don't want that one or that one. So those are 2 more lines that we're wanting to skip. We'd now be at the start of line 10, which is where we really want to begin processing our data. So our algorithm would then be our 1.5 loop pattern. Read a line, and then while the line is not empty. So we currently have our first line to be processed in memory. While the line is not empty, well, this line 10 here is not empty. So we'll split the line into pieces separated by commas. The date is piece index 1, because Christchurch Aero is piece index 0, and the date is that line index 1. Okay? We then get the month and the day from the date, because clearly we've got more than we want. We've got the year, the month, and the day, and we just want the month and the day, or the month and the date. And then sunshine is the piece index 3. So if we've split it into pieces, index 0 is the place, index 1 is the date and year, index 2 is the time, and index 3 is the floating point value for our amount of sunshine. So we need to turn that into a float, because by default it would be a string. And we then process the month, day, and the sunshine data point. So it might be write to another file, or as we'll do at the very end of this, it might be pipe it to a process that draws a graphical plot. And then we'll read our next line so that we're ready in our 1.5 loop pattern to see if the line we've just read is empty. If we get to line 19, for example, we've finished processing this file. We don't care anymore. Okay? So of course there are problems with this algorithm, like what happens if the data file does not contain the two expected blank lines, the blank line here and the blank line here. Well, unfortunately our algorithm will be broken. So we'd better hope that this format that we're looking at of the file here is actually a rigorous format, and that files will always adhere to that format. So our code to do this processing, well, on the left we have our very first version. What we're going to do is open up sunshine.txt. We can then read a line. So this is more or less directly translating from our pseudocode. Our pseudocode was read lines until we get an empty line. So we're 1.5 loop pattern here. We read an initial line. We keep reading lines until there is a line that contains nothing, i.e. it's just a new line. Okay? So skip lines until we get an empty line. Then read 2 more lines, read a line, read a line. Those are satisfying that component there. Then read a line, that's what we see right here. While the line is not empty, that's our termination condition. Split the line into pieces separated by a comma, that's exactly what we see here. Pieces equals line.split based on the comma. Then the date is pieces indexed by 1. We've got a very good translation from our pseudocode here. Get the month and the day from the date. Well, that's a little bit tricky. I'll leave you to think about why that's succeeding, and think about that in your own time. And then sunshine is the float of pieces indexed by 3, which we see exactly here. Okay, process the month, day, sunshine data point, which might be writing to another file. All we're going to do is print it out to the standard output, so we'll see it in the Python shell. And then read a line. There's our line. So if you understood the pseudocode, hopefully translating this into Python is really pretty straightforward. But probably the most tricky piece is the bit that I've left you to think about in your own time, but it's really just string processing, of which we did a lot earlier in the course. Last thing to do, it's always good manners to release our resources once we're finished with them. So if we've got an open file, it makes sense to close it once we're done with it. So we can run that, and we'll see we get a nice little tabular format of the days, of the months and the dates and the sunshine values. Of course, sunshine.txt, our file, actually only contained a very limited set of data. So that's why it's so brief. A separate example that we see in sunshine2.py is just it's starting to use functions a little bit better. So what we've done here is split out the part that processes just the data line. Okay, so this splits the line into pieces, it extracts the date, it splits the month and the day out from the date, and it extracts the sunshine value and prints out the data that we want. So the rest of the program is looking the same, it's just our loop is now cleaner, whereas the loop before contained all of this stuff. Our program was getting a little bit harder to understand than we'd want. We can simplify that by delegating a lot of the responsibilities of this loop to this function, newly defined function. So breaking things down, dividing and conquering, having a nice little separate function that processes the line independently. It's a pretty substantial improvement to the program, even though the program's slightly longer. Okay, we'll leave it there for this video. In the next video, we'll look at slight improvements to this algorithm and writing data to a file rather than standard output, and also producing graphical output. Thanks.